Hey guys, welcome back to walkthrough of chapter 5 spatial data, in which we'll be doing a bunch of stuff like exploring metadata, exploring map projections, and learn about vector data formats and explore sources of vector maps, raster maps, and how to download and process tabular data. So this is where I would begin. Let's open up the maps folder and open tutorial. Oh, I'm sorry, tutorial 5.1. Click open. So let's examine these two data sets that we have here, which is Allegheny County municipalities, which is this one, the one in the black outline. The one in the red outlines is the county layer. So typically these two should line up, but since this Pennsylvania counties layer doesn't have proper resolution, which means it was drawn at a pretty small scale, it has small amount of detail, which means when I actually zoom in, as you can see, I'm missing out on all the exact boundaries, and all I have is a bunch of nodes which are representative of the shape but not exactly following the shape. So somebody who drew this didn't actually care enough, or maybe that was not their intent, so we don't know. Either way, this map is pretty this layer, the Pennsylvania county layer, has poor resolution. So let's look at the metadata file for the Pennsylvania counties. What you can do is click on catalog, go to SRA press folder, under data, let's see where this Pennsylvania county layer is. So the one way to know where this layer is right click on the layer, go to properties, and click on source tab, and it will tell you where this layer is being drawn from. So it is under the United States GDB, it is called PA counties. So I'm gonna go to United States PA counties, right click on it and say item description. So once I click on that, I would get a new window, which, whoa, that didn't work out. Okay, let's try that one more time. Okay, I'm gonna click on don't send, reopen my ArcMap. So looks like I tried to do the same thing again using ArcCatalog. ArcCatalog, I tried to do the same thing, trying to explore metadata, but it looks like it's crashing on me right now. I don't have an answer for you why it's doing that. So it's just crashing on me all the time. So what I would do is try to figure out a solution, but in the meanwhile, let's just talk about it. So if you actually do get to the part where you can see the metadata, you can see that and also it's in the book, it says that the geospatial part of this data set was extracted from ArcUSA 1.25 million, 1:25 million scale database, then generalized. When something is generalized, which means that if there are like multiple vertices, when somebody like nodes and vertices, somebody draws this shapefile or shape, when something is generalized, it reduces the number of nodes and vertices. So essentially to save disk space, and it actually helps draw the layers much faster, but it also compromises on again accuracy. So This decreases the map size and increases processing speed. So Pennsylvania counties is not appropriate for use of scale of individual counties as in the current map document. So that's what you need to know. And if you scroll down and click on entities and attributes, you can also see that you can see FIPS is the combined state and county FIPS code. County and county FIPS codes would begin 01 and so on and so forth. It will give you all the attributes and what they mean. So you can explore this on your own if you are able to get to that part, if you are able to open that metadata window. So I'm gonna move on to Phi 2 because that's not working out essentially. So maybe there is a patch out there on esri.com. Maybe I can take a look at it when I can. It looks like there is a patch. Maybe I can download that. It looks like the 10.2.1 for desktop might be the patch. Since I'm using 10.2, I'm gonna have to download this patch and see if that actually works for me. So anyways, let's move on to Phi 2. I'm gonna open my map document Phi 2. Okay, I'm gonna work with map projections. Let's see what the map projection for this county is. Well, it says place your cursor on the westmost point on Africa and see that it's minus 16 to minus 15 degree, 15 degree decimal degrees. So essentially, so what that means is that these are the angles. These are the angles of rotation calculated from the Earth, calculated from the prime meridian on the equator. So these coordinates are really for viewing the map on a flat surface. As you can see, the North Pole is hugely distorted, so is the South Pole, and these should be actually points. So ArcMap has several and easily sort of like use any projection. So let's see if we can change this projection to Mercator. I'm going to right click on the layers, go to properties. I'm going to click on coordinate system, and I'm going to see if I have a world folder, which I do, and then click on scroll down to coordinate system, click so I'm going to find projected coordinate systems folder, under which there is a world folder, and then I'm going to scroll down and find my Mercator, click on apply. As you can see, the map instantly changed its shape, and it's more vertical right now and seems to have fewer distortions, so to speak. So and then so we can actually play with these projections all we want. So if I click on the globe view, it's gonna look like it's elongated. So each projection again actually serves a particular purpose, which means it's gonna reduce one of the errors, which is angle, shape, or size errors, or distance errors. So I'm gonna try another projection here. I'm gonna search for a projection. So there is a hammer 8 off. So it is actually a more representative view of the world, because it's actually wrapped around a globe instead of actually trying to show this on a flat 2D paper. And then there is the other projection is Robinson, which is actually a compromise between Mercator and Hammerite. So I'm gonna look for Robinson world. I'm gonna click on that, click OK. So as you can see, a projection matters a lot, because it's going to change the way you are viewing these shapes on your map. So depending on what you're trying to accomplish, your map's gonna have to use that kind of a projection. So let's open 5.3 and play with the United States projections a little bit. I'm gonna click no. Okay, so United States, when I open this, looks like this is in the decimal degrees. The map units are in decimal degrees, and I can see that this is not exactly what I imagined the US map would look like, but that's okay. Let's go and see what projection this is in. This is in NAD 1983 CSRS. So I'm gonna choose I'm gonna choose projected and see if there is a continental, North America, Albert's equal area conic. Let's use that and click OK. Wow, that looks more like what you would normally see US map to. That's the normal shape it should look like, US map should look like. So yeah, again, these are the type of things that you need to sort of like explore and know about, like some of these major projection names and stuff. So by selecting this projection, you're essentially this is the standard projection that is used by US Census Bureau. So you need to know that all the census data has to be projected. Perhaps if you download census data from the census.gov, since this is created to be viewed in this projection, it's better to use it in the same projection as well. So, and then you can apply your own projections if you want, but one thing we can try and explore is can we make the distances equal? So if I actually go to measure and click on measuring tool and measure, I don't know, vertex to vertex, something like let's do something which we can remember. So essentially Florida to Texas is about distance, let's change it to miles, is about 1000 miles, 1026 miles. But if we change that to equidistant, let's see if we can find North America equidistant. So the mile is slightly reduced. So as you can see, all of the projections look similar, but the thing is the smaller part of the world, since this is a smaller part of the world, the distortion is quite less, even though we change the projection from Alberts to um, the projection we just used, which is the equidistant North America equidistant conic. So what I'm trying to tell you is the projection becomes less and less significant depending on the part of the world that you're viewing. If you are only like concentrating on one state, this would be even a lesser deal, so to speak. So let's do not save the map right now. I'm gonna start my web browser and go to ngs.noaa.gov /tools SPC utilities. So state plane coordinates utilities essentially. So the reason why we are here is to figure out what zone we are in, what state plane coordinate system we belong to, based on where we are located. So since we are in Missouri, we can actually look at that zone and figure out like which state plane projection we should use when we actually do the mapping for St. Louis, Missouri. So I'm gonna click on by county. So since I know that the state is Missouri, you can essentially scroll down to St. Louis. Maybe it's city of St. Louis. I'm going to click on that and click on submit. So once I do that, I'm going to get the SPC results based on okay, that didn't go through. Let's try that one more time. So the book says let's look that up for Pennsylvania. Maybe that's what we should do, and go to Pennsylvania, submit, and then click on Allegheny. And now it looks like I'm having the worst luck today. Nothing seems to be working. I can't find the state plane zones, so I'm gonna just Google for it. State plane zone coordinate system zones map. I'm gonna see if there is something like that. Of course there is. So I'm gonna click on this map. The link that I essentially got looks like for each county there is like a zone, and then wow, that is sort of useful. So I'm going to click on right there. So Illinois, maybe there is something for Missouri. Let's see. Michigan, Mississippi, Missouri, Central East. So that's St. Louis City right there, and then St. Louis County. So the zones, the UTM zones are 15 and 16, and the FIPS zone is 2401, state plane zone 2401. So we need to remember that, because when we're gonna actually, you don't actually need to remember the number, because you can easily find that using ArcGIS. But anyways, let's look at the Pennsylvania thing, which is the I'm gonna So it looks like there are two Allegheny counties. One is in Virginia, one is in North Carolina, but there's nothing in. That's great. Oh, okay, it's a different spelling. Okay, anyway, so we are looking at Allegheny counties in FIPS zone 3702, UTM zones 17 and 18, but that's yeah, that sounds about right. So 3702 is what the book says too. So okay, let's go back to the map, and what we can do is click a new map, open a blank map, do not save your work, and then add data. I'm gonna just go to my catalog and drag and drop add municipalities from Allegheny County. So once I have that, let's see what happened here. I'm gonna look at the properties of this layer. I'm gonna go to click on source. So it says that NAD 83 Pennsylvania State FIPS 7302 and that's in feet. So this is already in the projection that we need this to be in, and since we added this layer as the first layer to the map, the data frame automatically assumes that the projection is NAD 1983 State Plains Pennsylvania South FIPS 3702. So our work is essentially done. So what I'm trying to tell you is that on the fly projections are actually assumed or copied from the first layer that you add to our map. So another thing to notice, since this is in Albert's, this is in the state plane coordinate system, is that, let's see something here. Go to XY. So the units here, as you can see, are in feet, which is great again. And if you, because this is based on all positive coordinates, and that the 0 0 which is the origin of these coordinates is at the lower left corner of Pennsylvania, because this is a state plane coordinate system. That's how these things work. So to change the symbology, we can change it to anything we want. Make it light gray, make it, I don't know, in the display tab I'm gonna make it you don't need to add a transparency, it doesn't look like it, but anyways, what we need to do is we need to add one more layer, add tracks, drag and drop tracks. I'm gonna move this up. I'm gonna do some visual things here. I'm gonna go with, so again, this is purely aesthetic, so it's up to you if you want to follow the same colors or not. So let's look at the tracks layer properties. I'm going to go to source tab again and see that this GCS North America, the geographic coordinate system is the GCS North America 1983, but yet these two layers line up quite nicely. That is because the first layer we added has a projection coordinate system first of all, and that this is in the right coordinate system that we need to use this in, which is the state plane Pennsylvania. And then the data layer assumed those properties, and once you added tracks, it automatically adjusted the data to actually fit the map based on the coordinate systems of municipalities. So that's how that's how you actually work with projections. So you need to figure out which coordinates, which UTM zone you are in. So you can go to web browser and utmworld.htm and then figure out what UTM zone you are in, or you can just like come here and UTM zone 17 and 18 for Pennsylvania, so which I already know that. So I'm not gonna do the web browser thing. Coordinate system tab. Let's right click on the data frame properties and let's check it out. Coordinates. So I'm gonna expand the projected coordinate systems. UTM. I'm gonna go to UTM folder. I'm gonna click on add 1983 UTM zone 17. UTM zone 17 north, and click apply. You see how the map slightly moved. So this is essentially, as you can see, the distortion is pretty minimal, because for me they both look almost the same. So depending on the area you're working, the projection is not going to matter that much, because the projection has a very minimal effect on especially small areas. So let's see how to assign a projection to a shapefile. So what we need to do is open a blank document, click OK. I'm not gonna save my work. I'm gonna right click and add Allegheny County tracks. Allegheny County tracks to the map. So as you can see, this looks significantly different from what we know Allegheny County should look like in the state plane coordinate system. But right click on Allegheny County tracks and go to properties and click on source tab. As you can see, this is in the GCS North America 1983, but we know this looks better in the state plane coordinate system. So what we can do is, so what we need to assign like the right coordinate system for this. What I'm going to do is, the book says something different, that this doesn't have a projection and all that. Oh, actually they may be right, because I got the wrong file. I'm gonna go back to our catalog. In the data files I have Allegheny County tracks. I'm gonna add that, and it says unknown spatial reference because the spatial reference has not been assigned. So I'm gonna click on OK. So I'm going to right click and go to properties, and says coordinate system is undefined. So what we need to do is assign a coordinate system for this layer. So I'm going to go back to my catalog, right click on this, go to properties, on the XY coordinate system tab. Let's remove this, and then on the properties tab I'm gonna click on XY coordinate system. I'm gonna browse to select double click North America projected coordinate system, double geographic. I'm gonna scroll down to North America and add 1983. I'm gonna click on apply and OK. So I'm gonna add that again. As you can see, a projection has been applied. I could have done the same thing, maybe applied a different projection using, for the state plane itself. Maybe I could have just typed, go to projected state plane 1983 US feet, and then I could have just scrolled down to Pennsylvania North, or this is the Pennsylvania South 3702 if I'm not wrong, and I'm going to click on OK. Now drag and drop that, as you can see, the projection has been changed. So that's how you apply a projection, apply a coordinate system to the layer. I'm going to remove this catalog, go to properties, and change this back to geographic North America 1993. Click OK. So I'm gonna add that layer back to the map again. So what I'm going to do is examine the shapefile. Let's see where the shapefile is. GST1 data files. So obviously this is in the lock mode, so don't worry about that file. That won't be there once you close out of the document. But what you need to understand is that we have a PRJ file. The PRJ file right here actually is the file that got created when we defined a projection using the process we just used. So the next step here is to close out and then explore coverages. Coverages, as we know, is an old ESRS spatial data format, and this was from the days before PCs. So anyways, this is these pieces of data are saved in something called workspaces or folders. They just look like folders for us. Anyways, let's add a coverage to a map. Let's go to, if you go to data and go to Pittsburgh and look at East Liberty. So all these are actually coverages. If you open each one of these, you will see a bunch of files that has no meaning for you. So anyways, these are coverages. They just look like folders to us. I'm just gonna, we can just go to this map document and click on add data, double click building, Pittsburgh East Liberty, double click building. So as you can see, each one of these coverages has all the type of features, like it has a polygon, it has a label, arc, annotation, and tick. So everything is saved as a separate separate type of feature, but ArcInfo sort of knows that these interact with each other, so to speak. So we'll learn how to convert a coverage into a shapefile. What we will do is add this building to the map, zoom to layer. As you can see, these are not lining up. So let's export this using our catalog in as a shapefile. So what I'm going to do is go to arc catalog. I'm going to go to my data, Pittsburgh East Liberty buildings. What I'm going to do is I'm going to click on the polygon layer. I'm going to click on create a layer. So I'm going to come back to my map document, add this building layer to the map. Don't worry about no spatial reference stuff. Right click on it, data, export data to chapter 5. I'm going to export this as a shapefile, buildings. I'm going to click on save, click on OK. I'm going to say no spatial reference. I'm going to remove this. I'm going to go back to my catalog, scroll to my chapter 5 folder. I'm going to right click on refresh. Oh, that's not assignments, it's my exercises. Chapter 5 buildings. I'm going to right click, go to properties. I'm going to assign the same coordinate system as my North America, GCS 1980, NAD 1983. Click apply. Okay, I'm gonna add that to the map. But still, these two layers are not lining up. This layer is here and looks like Allegheny counties is somewhere here, but these two are not at all lining up. So something's wrong. We need to edit this buildings layer to actually match up to the shapefile, the Allegheny County tracks, which we know is right. So we will come back and fix that a little later. So what we need to know right now is that these two are not lining up and that we need to work on it, which we will work on in chapter 6. So let's move on to adding a CAD file. So I'm gonna remove the in a blank new document, I'm not gonna save my work, and I'm gonna scroll to GST1 data. I'm gonna open CMU campus, in which there is a campus.dwg, which is a drawing file. I'm gonna add that to the map. So as you can see, the following has unknown spatial reference because this doesn't have a spatial reference. It's an AutoCAD file. This is a drawing of a campus map from 2005, it looks like. And then it has a bunch of stuff here. It has points, annotation, polygon, multi-patch, but what I'm interested is in only the polygon layer. So I'm going to right click and remove this layer, go back to catalog. I'm going to add only my polygon layer. As you can see, only the polygons have been added, so which are the buildings essentially. So but you cannot edit this layer because this is in AutoCAD format. You need to export it to actually edit this layer. So click on drawing layers tab, go to properties and click on drawing layers tab. As you can see, there are a bunch of layers like academic buildings, annotation, fence, handicap route, and all this stuff that were created, that were the layers in AutoCAD. So what I'm going to do is so all you need to do is explore this data at this point of time. If you want, you can export data to like a shapefile, but I'm not going to do that right now. I'm going to click on a new blank document, and then I'm going to add catalog, add. I'm going to go to my Pittsburgh folder, and under Pittsburgh CBD, Central Business District, I'm going to add Central Business District.gdb, CBD streets. I'm going to add that to the map, and now I need to export this to a CAD format. I'm going to right click, I'm going to click on catalog, or I'm going to click on my Windows and enable the search feature, or you can do it from the ARC toolbox. I'm going to click on tools. I'm going to search for CAD. There's something called to CAD. So export to CAD. So once I have that window, I'm going to drag and drop my CBD streets onto the window into the add data, or you can just like select right from right there. And output type, you can select drawing output. I'm gonna select drawing R2007 format. I'm gonna save this in chapter 5. Obviously my exercise is chapter 5. I'm gonna call it CBD streets and click OK, and see what that looks like in my my exercise is chapter 4, chapter 5. So it looks like a CBD streets a drawing file has been created. So as you can see, this actually follows the same format as if I turn that layer off, same format as the other drawing file we added. It created a bunch of layers like point, polygon, multi-patch, annotation, CBD streets. So again, that's how you actually export CAD files to our shape files to CAD. So let's work with the XY events file. What I'm going to do is a new blank document, click on OK, and now I'm going to add data, our catalog data. Under data files there is earthquakes.dbf. I'm going to add that to the map. I'm going to right click, I'm going to explore the data here. As I can see, there is an X and a Y field, so which means we can use the XY events procedure to actually display this earthquakes layer. So I'm going to right click on the table and click on display XY events. I'm going to click X, select X for X and Y for Y, and I'm going to select edit the coordinate system, and I'm going to select GCS North America 1983, which is actually in my favorites, or you can just search for GCS North America, or you can just type in GCS _North. Then in the North America you do get a bunch of stuff. I'm gonna just search for GCS and see what comes up. And I'm gonna click on OK, and it's gonna map out all my earthquake events based on again, if you look based on the XY's latitudes and longitudes we just provided, we can add the CA counties because this looks like a California data. We can go to United States, CA counties. But what we need to understand here is that this file has been created in the data files layer under called as earthquake data files. If you refresh this, you can't really see the data because it's temporary data that's just been created. I'm gonna have to export this to actually make it a more permanent layer. So just remember that and move on to 5.4. Explore sources of vector maps.